You've probably turned in a physics or chemistry exam or homework assignment feeling pretty confident that you got everything right, only to find out that you lost points simply because you didn't put the correct amount of sig figs. It's pretty annoying, right? So let's fix it once and for all. In this video, I'm going to show you the exact rules that teachers expect you to follow. And more importantly, by the end of this video, you're going to walk away with a powerful and intuitive understanding for why sig figs even matter in the first place. And if at any point in this video you learned something insightful, just consider sharing what you learned down in the comment section, because it could be the one thing that someone else needs to really master this subject. And that's what this channel is all about, sharing our information of physics, chemistry, science, and math so that we can just be better as a whole. So let's get started. First, we're going to talk about why sig figs even matter. And here's the insight that changes everything. Every number you work with has to come from a measurement, and every measurement comes with built-in imprecision. So let's take, for example, a scale weighing a block, and we get the following three measurements. As you can see, these three measurements aren't exactly what the block actually weighs, and it is this built-in imprecision that ends up flowing straight through our calculations. And that is why significant figures exist. They're here to keep our answers honest about how precise or imprecise our data actually is. And once you really internalize this, the rules for rounding, addition, multiplying, subtracting, and dividing sig figs, they stop feeling random, and they start to really mean something that is logical. So next up, we're going to cover exactly what those rules are. So when you add and subtract numbers, I want you to think about rounding your final answer to the least amount of decimal places given. So for example, let's take the following three numbers: 17.8, 15.678, plus 15.65. In total, this is going to yield 49.128. Now, when we round to the nearest significant figure, when we add or subtract, that is rounding to the least amount of decimal places given, which in our example is 17.8 decimal place to the tenths place. So we know that our answer has to be rounded down to the tenths place, giving us 49.1. Moving on, when you multiply or divide, you want to round to the least amount of significant figures given. So for example, let's take 5.00 times 5.0 times 5. Of course, an unrounded answer is going to be 125.00. However, the least amount of significant figures given is actually 1 because of this 5 here. So our answer is actually only going to have one significant figure. Therefore, we round down to 100. Again, this low imprecision from our given numbers dominates the entire calculation, and our answer has to reflect that amount of imprecision. The first mistake I see students make is believing that they are losing precision. In the example we just covered, we saw how we had to round 125 down to 100. And a lot of people make the error of thinking that we lost accuracy because of that. But here's the truth. You never actually had that amount of precision to begin with. Sig figs don't take precision away. They actually are here to keep us honest about the precision we started with in the first place, which came from this one significant figure. The second mistake I see students making is misreading the trailing zeros. So for example, 500 is only one sig fig, it's a whole number, but 5.00 is a more precise measurement. It actually has 3 sig figs. Although they have the same number of digits, they have different number of significant figures. And once this starts to click, your understanding of measurements becomes so much more powerful. Now, let's take what we just learned, combine it, and apply it to one problem in which we have both addition, subtraction, multiplication, and division using significant figures. And here's a bonus tip for you. When you're doing multi-step calculations, you actually want to leave your answers unrounded until the very final step. So for example, we know that 4.57 plus 4.2 is actually equal to 8.77. Our correct rounded answer to significant figures should be 8.8. However, since we're still in the middle of this calculation, we're going to leave that as 8.77 until we get to the very, very final calculation. We're going to write it as 8.8, of course, and keep working with that number. But when we go to plug it into a calculator, it's going to be its unrounded answer. So your first step is to add and subtract the top row of numbers, which should give you the following answers to the correct significant figures. Remember, when we go to perform this next calculation, we're actually going to leave the unrounded answers in our calculator. For our second step, we're going to just go ahead and multiply and divide everything at once, which yields 2.9478. Remember, we need to round this to 1 sig fig because of the final multiplication step needing the least amount of significant figures. So this is actually going to round up to simply 3. And that's going to be your final answer, correct to the correct amount of sig figs. So I'm going to share 3 things as a summary for you. Remember, number 1, when you add or subtract, I want you to think about matching the decimals. And when you multiply and divide, I want you to think about matching the amount of sig figs. And lastly, I want you to really internalize this last concept. Sig figs don't cause you to lose precision. They keep you honest about not even having it in the first place. So with these 3 insights in mind, you're going to have a powerful, intuitive framework for handling your precision in every physics, chemistry, engineering, mathematics class you'll ever take. So if this helps solidify your intuition, drop a comment with something you learned, what was insightful for you, because it might be exactly what helps another student finally understand this. And again, that's what this channel is all about.